Hello, 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 ladies and gentlemen. Root Beer here, and I hope you're all doing well. And you're as excited as I am to start question number 22 on our 2009 Grade 7 Gauss paper. So here it is. Here's question 22. And what have we got? In the diagram, a 4x4 grid is to be filled so that each of the digits 1, 2, 3, 4 appears in each row and each column. Well, if there's 4 numbers in each row, and 1, 2, 3, and 4 have to appear in each row and column, then each number appears exactly once. So this looks a lot like something called a Sudoku, which was quite popular in the early 2000s. You know, it's still, you'll find them in newspapers and so forth, but it really did explode in the early 2000s, which I guess this contest is from the late 2000s, but this is sort of like a mini Sudoku almost. The 4x4 grid is divided into 4 smaller 2x2 squares, and each of these 2x2 squares is also to contain 1, 2, 3, and 4. So this is exactly, it's just a 4x4 Sudoku. Normally they're 9x9, and so you get a 3x3 grid of smaller 3x3 grids, and the numbers 1 through 9 have to be placed. They're quite interesting. My mother loves these. She has a giant book of Sudokus, and they're very interesting things to look at. So you might not now, but perhaps in your future, you might go into high school and take a look at computer science classes, which I do highly recommend. Computer science and math, they gel very nicely together. It's about logical thinking and organizing your thoughts into an algorithmic and orderly process. You know, step by step, I do this, I do this, I do this. And one of the challenges I remember in one of my computer science classes was to build a program that if somebody types in a Sudoku, it'll compute the answer really quickly. It's quite nice. That's not what we're here for, but it's something interesting and something to look into. So Sudokus, if you haven't heard of them, are great, and they're nice, and they lend themselves to a cute little computer science problem to try someday in the future. So each of the 2x2 squares has to contain a 1, 2, 3, and a 4. What digit replaces p? And so we have possibilities 1, 2, 3, 4, or I can't figure it out. Well, not I can't figure it out. It's no one could figure it out. There might be, it might be the case that you could have a 2 or a 3 there. It entirely depends on your preference. I'm inclined to believe E is not the correct answer, but who knows? Who knows? It might be the one time that doesn't happen. And maybe part of this question is being able to admit, nope, you can't keep going. There's no way to deduce it any further. So what I'm going to do is I'm going to copy this sort of 2x2 Sudoku. And we're going to copy what we do know about it. So 1 blank 3, 2, there's a 4 down here. And I'm going to do 2 things. One, I'm going to highlight the specific 2x2 boxes so that I'm always aware of those. You'll notice in the question they make it bold. And then I'm also going to, in green, highlight the box that has P in it. That way I know when I've got my answer. Okay, and I think I will, just in case I realize that I've made a mistake at some point, I'm going to keep the original numbers in black. I'm going to make my deductions in blue. Okay. So, well, depending on your experience with Sudokus, you might be flying through this question. But we need to sort of focus on some of the numbers that we have and use them to work out numbers that we don't have. So something I would probably do right away is I'd look at this box here, this blue box here, because it's inside a big 2x2 square that already has a 1 and a 2 filled in. So 3 and 4 need to be placed. Does the 3 go here, or does the 3 go here? And if the 3 goes down here, then it must be a 4 up here. Well, that's where this 3 over here comes in, because remember, in every row, you need to have a 1, 2, 3, and 4. Well, this row already has its 3. So you can't place a 3 here. Which means it has to be the other possibility, which is a 4. So 4 has to go there. And if 4 goes there, well, to complete this upper left 2x2 block, we must get a 3 here. Okay. Now, let's take a look at this upper right 2x2 block. Okay, because it's also got some stuff filled in. The 2x2 block that has where P is doesn't really have a whole lot of numbers filled in. So I think we're probably going to end up going sort of clockwise. We're going to start up here, move to this one over here, and then work out this one, and then maybe we can finally get the bottom left block. But let's take a look here. Now, this 4 down here tells me that I can't have a 4 in either of these two. Okay, but I do need a 4 in one of these 3 squares because it's a 2x2 block and we need to have a 4 somewhere. But I can't have a 4 in this 4 column, so I've got to have a 4 here. And then now look at this row. I need to have a 1, 2, 3, and a 4. Well, I've got the 2, 3, and a 4. This has got to be a 1. Similarly, we've got 1, 3, and 4 taken in this top row. This will have to be a 2. And now I can fill in this box right here. 1, 2. So 1, 2, 3, 4 fills in this column right here. Okay? I am trying to go through this slowly and explain my processes. To fill in this sort of thing, you just have to check all 3 rules, you know. Rows have to have the 1, 2, 3, and a 4. Columns have to have the 1, 2, 3, and a 4. And these 2x2 blocks have to have the 1, 2, 3, and a 4. Now, for the remaining 6 squares that I don't know about, it's a little tricky. I don't have a whole lot else I can work with. Now, I've got a 4 up here, which tells me that I can't have a 4. So here's something that I do on Sudokus when I get stuck, and we'll use purple. I say, well, each box could have a 1, 2, 3, or 4. I really only break this out if I'm very, very stuck, but you might find this helpful for the question, or even just sorting things out. So each could have a 1, 2, 3, or 4, but neither of these 2 blocks can have a 1 or a 3 because they're already picked up here, so just get rid of them. So now I know these blocks can have a 2 or a 4. Similarly, we can't have a 2 or a 4 here either. And thanks to this 3 over here, you can't have a 3 or a 3 here. And that 3's already been crossed out. Or you can't have a 4 or a 4 here. And thanks to this 3 and this 4 up here, you can't have a 4 or a 3 here either. Okay? Now look what that's done. And we actually solved the question quite some time ago because I crossed out the 2 here, the 3 here, and the 4 here, and that leaves only the 1 here. Similarly, we have a 2 down here. So we've answered the question. P is going to have to be a 1. I just feel, we've got a little bit of time here. Well, frankly, I've got as much time as I want. It's a video. I'm not actually writing a contest here. But I'm going to finish off the whole grid. But just know that we already have answered. P is going to be equal to 1. We can, if you just want to move on, by all means, go ahead and do that. But we've got this 2 here, and that crosses out 2's here. So this is going to have to be a 4. This 1 crosses out this 1 here. This is going to have to be a 2. This is going to be a 1. And that leaves a 3 down here. And we actually have finished the whole thing. But to answer the actual question, and it's fun sometimes to keep going on a question, but when you're actually writing a contest and you only have an hour to go, as soon as you've got your answer and you're confident in it, move on. Give yourself time to play around with the other questions. So P being 1 is an answer of A. So there we go. That's question 22. We'll flip the page to get ready for question number 23. I will see you guys for that in the next video. Until then, have a wonderful day.